This is your intermediate paper 1 revision. It's a little bit late getting to you. Apologies. I know the exam's either tomorrow or the day after, but hopefully you can have a quick look through it. For those who didn't take the paper version of the revision sheet home, I'm going to do my kind of notes on this page, and then if you want to, you can pause and try some of the extra questions that are there to make sure you're happy, okay? Otherwise, just listen to the video through. The other option is to do revision on MathsWatch, but I certainly would watch this through. So the first question that we've got in our revision, I hope the pen works okay now. Let's just check. It'll do. Okay, is working with decimals, all right? So a decimal addition, I actually can take the top one here. Now, if it's set out like this, you need to be able to put, line things up. 1.7, notice, and if there's an extra decimal place, it goes at the end of the number. We can always fill in that with a 0, okay? And there might be an add. I also think there might be a subtract, okay? Here, 0 take away 3 can't be done. 3 is bigger than 0, so I need to borrow 1 from here. 10 take away 3 is 7. All right, why am I doing that? I'm doing take away first. 4 take away 7 can't be done, so borrow 1 from here. 14 take away 7 is also 7, and 5 take away 1 is 4. That was a good start, wasn't it? Seeing that's an add though, but useful, because if we were adding them, plus 1.73, even easier. 0 add 3 is 3, 5 add 7 is 12, which is 2 carry 1, and 6, 1 and 1 makes 8. Apologies, the pen isn't great, but we'll keep going. Multiplying, again, easy enough. Set it up like that. 3 4s are 12, carry 1, 3 1s are 3, add the 1 down there is 4, decimal place in the same place, 3 5s are 15, and a division, and we'll take the last one, okay, it's set up like that. So 4 goes into 8 twice, put the decimal point again in position, 4 goes into 5 once, remainder 1, and then the 4 goes into 16 4 times. Question 2, we're going to be multiplying decimals by decimals, unlike question 1 where we did sort of a decimal number by a whole number. Slightly different here. We're going to do these in our head. So I'm going to pick on 2 examples here. I'm not going to do any of the ones that are actually there. I'm going to do 0.4 times 0.2. Okay, 4 2s are 8. But because that's only 1 digit, but I need 2 digits after the decimal point, I'm going to have to put a 0 before it to make 0.08. And the other example I'm going to do is 12 times 0.4. 12 times 4 is 48. But this time I only want 1 digit after the decimal point, so I only need to jump back 1 from the end. And then there's only one number after the point, so it's 4.8. Not a lot to say here. Let's take this one. Okay, if I'm timesing by 1,000, then the 4.1, I'm jumping that 3 times this way. So 1 jumps it to the end, then another jump adds a 0 on the end, and another jump adds a 0 on the end. So it's 4,100. Compared to this, if I'm dividing, I'm jumping this way. So 1 jump moves the point to the beginning of the number, another jump puts a 0 there, and another jump puts a 0 there. But remember, this way I actually need to put the point in its new position, so it's 0.0041. Estimating, okay. So this would be 6 times 7. Right? I don't like this. I don't think it quite works. Okay, so I'm going to write my own one here, if that's all right. I'm going to do 31 times 398 divided by 184. Okay, right. If I were rounding these numbers, that is between 10 and 100, so I would round it to the nearest 10. That is between 100 and 1,000. It's bigger than 100, so I would round it to the nearest 100. as is the number we're dividing by, which is also bigger than 100, so I would try that to the nearest 100. Told you my voice is boring. Okay, now I've got to work this out. So do the top bit first, do the times bit first. 3 times 4 is 12. Okay, and put your zeros on the end. 1, 2, 3 zeros there. Okay, 1, 2, 3 zeros there. Divided by, we've still got to divide by 200. Okay, interesting one when dividing. When you're dividing, you can cancel zeros. Okay, so 12,000 divided by 200 has the same answer as 1,200 divided by 20, but that has the same answer as 120 divided by 2, and I can't cancel the last zero because I've run out of zeros on the bottom to cancel it with. So 120 divided by 2, or half of 120, is 60, and that's my estimate for that question. Square and cube numbers. So your square numbers are 1 squared, which is 1, 2 squared, which is 4, and if we keep going, just think in your head, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and all these are square numbers. So in this list, the square numbers would be 4, because it's 2 times 2, there, okay, 16, because it's 4 times 4, right? And the other dodgy one, and the one you maybe, because it's a higher square number, okay, is 81, because that's 9 squared. And even more difficult to pick out here, 121, because that's 11 squared. Don't think there are any others. Nope. Whereas cube numbers means times by itself 3 times. All right. So if you're ever doing that, you'll do 5 times 5, you do the first bit, you square it first of all, get 25, and then take your answer and times that by 5, which is 1, 2, 5. You also need to be aware in this question, I guess, of cube roots, okay? So the cubed root, which you show by a little 3 there, of 125, is 5, because 5 times 5 times 5 makes 125, okay? Right, a little bit of bid mass. Which one should we do? Well, let's do the last one then, is it? Okay, so we start with the brackets here. So we're going to do that first, which is 3, right? Then what would come next? The multiply would come before the add, that's that, okay? So 5 times my answer to this, which is 3. So it's 15, but I still haven't added that 4 on the end. And now I can do that add bit and get 19. You can try the others. Now, in one like this, where you have 2 multiplies, you just do them at the same time. Okay, so that's 15, that's 12, then add the answers. Substitution. I'll use these numbers here, okay, A equals 7, B equals 10, and so on, but I'm going to just make them a little bit harder than this. So I'm going to do 2D take away 5C, and then I'm going to do B squared take away A squared. They're the ones I'm going to look at, okay? So 2 lots of D, 2 of these, which is 16, take away 5 C's, 5 lots of this, which is 15. So that's 1. And the second one of my examples is B squared, B times B, 10 squared, well 10 times 10 is 100, take away A squared, 7 squared, which is 49. Okay, and then I've got to work that out, and that's 51. I don't think, let me just quickly scan the exam, bear with, all right? I don't think I'd worry too much about perimeter. Okay, perimeter is how far it is around the shape. No, probably should do both. Yeah, no, we should do both. Okay, let's take this one, all right? So the area is 12 times 2, which is 24 centimeters squared. The perimeter is 12 add 2, but with perimeter, imagine sort of a little person here taking a walk all the way around. So not only would he walk 12 and 2, he'd then have to walk another 12 and another 2 to get back to where he started. So all in all, he's walked 28 centimeters. just bear in mind something like this. What if I said to you, if I double these, does the area double and does the perimeter double? With a yes or no, okay? Well, if I double them, the area would become 24 times 4, and if you work that out, it's 96, which isn't double that. It's way more than double that, okay? However, the perimeter would become 24 plus 4 plus 24 plus 4, which is 56, which is double that. So if you double the length and double the width, the area will more than double, but the perimeter will double. And if that doesn't make sense, don't worry, just remember how to do area and perimeter. Should be enough to get you some marks in that question. Solving equations. Right, the top line, there's only one thing to do. Opposite of plus 5, take away 5 from there. Opposite of plus 2, take away 2 from there. Opposite of take away 1, add 1 on there. Opposite of take away 4, add 4 on there. So you're doing magic bridge stuff, solving equations. Whatever you do into the letter on the left-hand side, do the opposite to the answer on the other side. Then we've got these two-step ones. Okay, I'll take a look at F here, and you can then try D and E. Okay, if I was doing F, the first thing I would move is the minus 4, and over here I would add 4. That leaves me with 8m equals 24, and then 8 times what is 24? How many 8s go into 24? Or I should say, what is 24 divided by 8? So m needs to be 3. Something a bit different, this one, okay? We only mentioned this once. The plus 4 still comes over as minus 4, like we've done in all our questions so far. But when you've got x's on both sides, you also have to move the 3x over to the left-hand side, the x side, okay? And a plus 3x here, I'm sorry, this is in the way, this area. A plus 3x here actually becomes minus 3x on this side. So the plus 4 becomes minus 4, and the plus 3x becomes minus 3x. So we now have two sums to work out. On the left-hand side, we have 5x take away 3x, which is 2x. And on the right-hand side, we had 16, and from that, we're taking away 4, which is 12. And then we're kind of in the same place as we have been in the last example. We've got to work out how many 2's go into 12. What is 12 divided by 2? And the answer is 6. Try this one, okay? But I'll just get you started. So remember, plus 1 over there as minus 1, and plus 2x over there as minus 2x. See how you get on. Rules of indices. Again, I'm going to pick out the ones that are most important for you. Honestly, let's just do A, B, and G, okay? In A, you add the indices. In B, you subtract the indices. And in G, you multiply the indices. So they are the three rules. If you're multiplying letters, you will add the indices. If you're dividing letters, you will take away or subtract the indices. And if you've got a bracket with a power, then you will multiply the indices to get 45. Fractions of amounts, not going to do it. Divide by the bottom, times by the top. Oh, come on, I'll give you one answer. 32 divided by 4, 32 divided by the bottom is 8. And then take your answer 8 and times it by the top, and it's 24. Operations with fractions. Okay, multiplying is the easiest. If you're multiplying, you multiply the top, 1 times 3, 1, 3 is 3, and then you multiply the bottom, 4 times 5 is 20, easy. Let's do divide next. In a divide in fractions, you change the divide to a times, okay? But in order to make the sum work, if you change a divide to a times, you flip this fraction around. So the 8 goes on the top and the 7 on the bottom. So the answer is 1 times 8, which is 8, and 2 times 7, which is 14. Now, let me just check if the question would ask you to simplify your answer. No, it doesn't. There's no need to simplify these. However, if we were simplifying this fraction, okay, we could half the top and the bottom, something we couldn't do with the answer above. All right. Now, for adding and taking away, the bottom numbers need to be the same. Here, the 3 times table is 3, 6, 9, 12, so on. The 2 times table is 2, 4, 6, 8. Okay. In both these times tables, the 3s and the 2s is 6. I am going to aim to make them both the same, both 6. To get the 3 to be 6, I double it, so I also double the top. To get the 2 to be 6, I triple it, so I'm also going to triple the top. And once the bottom numbers are the same, the bottom number doesn't change in the answer, but we can add the top numbers to make 5. If it was a takeaway question, we do it exactly the same way, but we would take away the top numbers from each other. Sharing in ratio. Yeah, easy for you guys, isn't it? Let's just do this one. So add those together, first of all. Okay. Take this number here, part 2, and divide it by whatever they add up to. In this case, they added up to 7, so the answer is 5. All right. So add, divide, and multiply. Take your answer here, which is 5. Okay, take your answer here, which is 5, and multiply it by the first number in the ratio. And that tells you how many sweets the first person gets. Then take the same 5 and multiply it by the second number in the ratio, 15, and that tells you what the second person gets. And the way I remember this method is Adam. Add, divide, and multiply. Adam. Lovely, 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 lovely. We're getting to the harder bit of the paper now, but we aren't far off the end, which is lovely, okay? Describe the rule. This isn't nth term. This isn't nth term. Because if it was nth term, it would say, what is the nth term? The rule, for example, this one here, the rule is +4. Right? This one here, the rule is times 2. Double it, double it, double it, double it. Here, the rule is take away 1. Right? There's the rule. But more importantly, what are the next 3 numbers? Can we continue that rule? So here, if we're going up in 4s, it would be 26, 30, and 34. Or if we were doubling, it would be 80, 160, and 240, etc. Okay, simplifying fractions. Let's look at this one. Both in the 5 times table. How many 5s go to 5? 1. How many 5s go to 15? 3. 9 over 12, both in the 3 times table. How many 3s go to 9? 3. How many 3s go to 12? So basically, you're dividing the top and bottom by the same thing. Most of these, A, C, and E, will probably involve dividing by 2. I just picked out the one that was dividing by 5 and one that was dividing by 3. Standard form, this one, 8 times 10 to the power, put an imaginary, well, it's not imaginary, it is there, we just don't see it. Put the decimal point at the end of the number and jump. 1 jump over that 0, 2, 3, 4, 5, 6. And that goes as a little number there. Or vice versa, jump to the end of this one, number 1, 2, 3, 4, 5, 6, 7, 8. Okay, and if we jump right the way to the end here, then we go past the 4, and the answer is 4 times 10. But because we're jumping down the number, the indice this time is -8. Okay. We've got I think these probably better off should have been in brackets. I just prefer them. I don't know why they're not. Okay. So here, if we were doing this one, we can multiply those and then multiply those. So let's start with the numbers. 4 times 2, which is 8, and then times 10 to the power 8 times 10 to the power 5 is a little bit like this here, because we're timesing the same thing. And when we times the same thing, right, then we add the little, so the number actually 10 doesn't change, but we add the little numbers to make 13. So that's how you multiply bits of standard form. Multiply the numbers and then write times 10 and add the little numbers. Now, adding with standard form, harder. Can't do it as easily as you can multiply. In fact, you're best off changing them to numbers. That's meant to be a 0. My pen is starting to lose the plot, okay? So I've times this by 10, then another 10, then another 10, and then a fourth 10. This one, I'll times it by 10, 26, then another 10, then another 10. So it's a smaller number. So if I was lining them up to add them up, the 6 would go under that 0, and the 2 would go under that, and there wouldn't be anything under the 3. Now I can add them. And then I can take my answer and put it back. 3, that is 0.9. Put it back into standard form. How many jumps? 1, 2, 3, 4. Okay. Another area and perimeter with rectangles, but this time rectangles stuck together. Okay. For area purposes, I'm going to need to split this up. Right. Let's do this one slightly harder. Could I just split like that? Or across? Okay. Now, I'm going to change my mind here. I'll explain why in a sec. I'm going to get rid of that. I'm going to split across. I think the numbers look a bit nicer. I might be wrong. This rectangle is a 6 by 2 rectangle, right? This rectangle down here, which I'm going to show by putting lines the other way, this rectangle down here isn't 7 in length, okay? In fact, who knows, we're going to have to work out the length and the width, right? So the length of this, the side of this rectangle is 7, take away this 2 here, so this is 5, all right? And the width of this rectangle is 6, take away 3, which is 3. So it took a bit of working out. So it's 5 times 3. Once you work out both your answers, 12 and 15, you can add them together to get an area of 27 centimeters squared. Perimeter-wise, are there any numbers missing? No, I've got 6 for that. So I've got all the way down there is 7. I've got 3, I've got 5, I've got 3, I've got 2. Perimeter, again, is the little man walking around. How far does he walk? So I'd expect you to write 6, 7, 3, 5, 3, 2, and add them all together. 13, 16, 21, 24, 26 centimeters. That's a 6. There we go. Last two, hurrah! Product of primes, trees, okay? So let's do the first one. You can try the others, 600. Now, I often encourage you to try and put a prime number there, which you could. You could do 2 times 300, right? The thing is here, we're aiming for branches that end with 2, God, believe it or not, that's meant to be a 3. 2, 3, 5, maybe 7, right? The next prime number is 11, I doubt it, right? So you could do 10 times 60, but I'm not. I'm going to start by seeing if I can half this number, which is 2 times 300. That is a prime that can stop. This, I'm going to go again. Again, I think I can half it. I haven't got a calculator, but I'm okay. Yeah, I can do that. I'm going to half it again, actually. So I've been able to use 2 quite a few times there. Divide by 2, divide by 2, divide by 2. I'm struggling now. There's no point me trying to work out how many 2's go into 75. I can't half it. It'll be a decimal. I don't want that. But because it ends with 5, I'm going to go see if I can find how many 5's go into 75, right? I'm going to need a bit of work out here. How many 5's go into 75? I haven't got a clue. 5 goes into 7 once, remainder 2. 5 goes into 25, 5 times, so that's 15. Still not finished because 15 isn't in my list there. 15 is 3 times 5. Okay, they are both in the list. In terms of writing this in index form, the number 2 appears 3 times, times the number 3, which only appears once, times the number 5, which appears in my answer twice. HCF, highest common factor. Okay. What is the biggest number? What is the biggest factor that is common to both the numbers? So is there a factor of 21, which is also a factor of 49, right? Now, in this case, I can spot they're both in the 7 times table. So 7 is a common factor. Am I 100% sure it's the highest one? Not really, okay? You probably would get these right with a guess, though. So my guess here would be 7. My guess here would be 5. My guess here would be, right, there's a, you might put 3, but it would be wrong because 3 is common, but actually 6, okay? You can do it like that. You can go, right, what is the biggest number I believe that goes into these? However, you can also do this, as we did, in class, by doing 2 of these, okay? So I won't actually do them, but 18 is 2 times 3 times 3 if you did a little tree. 45 is 3 times 3 times 5. Okay, again, you do that with product of prime trees, okay? And what you do then is you pick out ones that are in both. So there's a 3 here, which is also there. So I can take that 3 and put it outside there. There's another 3 here, which is also in here. So I can take that out as well. The other numbers, there's a 2 in the first one, but not in the second one. There's a 5 in the second one, not in the first one. So my highest common factor here is 3 times 3, which is 9. But again, you might have guessed that. You might have spotted, look, they're both in the 9 times table. Okay? So I'm not saying you have to use a method, but that is the method if you wanted one. And finally, right, the hardest. Don't worry if this hasn't sunk in. We're going to do more of this after the exam. We've got 1 here with same signs, subtract, okay? But I'm going to focus on A and B with a plus and a minus, or a minus and plus. Different signs, add. Let me pick the one that I think is the most suitable one to try right now. We'll take this second one, okay? Now, before, these are different signs. So in the exam, because they are different, a plus and a minus, my choice is I'm going to add these together. That should eliminate the y's. But if you remember back to a couple of weeks ago, we did this, okay? Before we can add them, we have to make the y's the same. Now, there's not a number there, but think of that as 1y. To make that be the same as 3y, I could do with tripling this, okay? I'm going to write these again. 3x minus 3y equals 9. I've decided to leave that one alone, do nothing to it. But the bottom one, I've decided I'm going to triple it. So I'm tripling every single part. 3 times 2x is 6x. 3 times 1y is 3y. 3 times 12 is 36. Now my y's are both 3y. This is where I employ their different signs. So I'm going to add these together. I add my x's. When I add my y's, they disappear. And I add my numbers to get 45. Again, we've done this when we were solving equations. If 9x is 45, then I need to divide the 45 by 9 to find what x is, 5. Okay? Now, we didn't do an example like this because we just run out of time and we're coming back to simultaneous equations after the exam. But to find y, when you've got 2 equations and one is a minus equation and one is a plus, I always think it's far easier if I'm picking one to work with now, pick the one that had the plus. Okay, we talked about pizzas and burgers or pens and rulers, I can't remember, right? But in this order, I have ordered 2 x's plus a y, and the cost, the answer is 12. But I now know that whatever these x's, a pizza, whatever, that if I put 2 of them, 2 x's, and each one costs 5, 2 x's will cost 10. So I'm just changing the 2x to 10 because I know x is 5. So 10 plus what makes 12? Well, y is 2. And that's the end of paper 1 revision. There'll be a video like this coming up. I'll probably go on Monday now, or Monday evening, for you to watch it the night before that. All the best with your revision. Stick some notes in Teams if you want anything explained a little bit more clearly. But with that being said, I shall bid you farewell, if I know how to cancel the video, that is. Bye-bye.